Aloha! This is Instructional Design and Development Part 4, Instructional Strategies. I'm Dr. Catherine P. Fulford, Professor, Learning Design and Technology, University of Hawaii at Manoa, and I'd like to thank Dane & Scheme, my editor. I'm going to put up a phrase, and as you read the phrase, I would like you to count the number of F's, the letter F, in the phrase. How many did you see? If you said 3, you're incorrect. Let's look back at this. Oh my goodness, there are actually 6. Notice the 3 F's in the ofs. The moral of this story is that when integrating educational technology, you have to know a lot more about education than you do technology. When we think of instructional strategies, what comes to mind often is the difference between a curriculum designer and an instructional designer. A lot of people think that these are the same thing, but often that's not true. So what is the difference? A curriculum designer is often hired from within the system, usually in a K-12 environment, and they are often teachers who develop curriculum for other populations of teachers. They usually do this based on content, for example, what to teach. Instructional designers, on the other hand, are not usually the content expert themselves, but hire content experts to do the work. Their focus instead is on the process. It's based on the learner and how to learn. Another debate that often rages in the instructional design world is what is the difference between instructional design and constructivist theory. I hope to put that to rest today. Using a systems approach model to instructional design, a lot of what's done is called the front-end analysis. Generally, in a constructive approach, this isn't used. So instructional designers set goals and objectives that have to do with the domains of learning, whereas extreme constructivists, and I'll say extreme because there can always be a combination of the two, allow a path to emerge. Gagne's learning outcomes are important to instructional designers so that we know that we're designing for the right domain. Instructional design also uses instructional analysis based on those domains. So, instructional designers looking at a constructivist approach would say that developed strategy is exactly where constructivism comes in, and we can choose that as an approach or not, depending on the situation. This is where instructional designers would believe that constructivist methods are used. Strategies can be either inductive, where the instruction provides all of the information, or deductive, whether the learner provides the information. Deciding how these are used has to do with several things. Inductive strategies are often called direct strategies. Deductive would be more like constructivist. You can also use the word supplantive. In other words, we supplant, as a designer, the materials that they need, whereas constructivist strategies are sometimes called generative strategies, where the students generate the information. Usually, supplantive strategies take less time, and generative strategies take more time. So let's look how we choose. The more time you have, the more you can choose a deductive strategy. If you have higher aptitudes, you would choose deductive, but lower aptitudes, you would choose more direct. Prior knowledge, direct if you have less prior knowledge, deductive if you have more. The criticality of task, you might actually want a combination of both of these. People learn more deeply with a constructivist method rather than a direct method, so that would be a good strategy in that case. Or if there's future learning required, again, you may want the deeper learning in a constructivist method. So here's an example. If you are going to teach surgeons about AIDS in an hour-long workshop, which method do you think you'd choose? Probably a direct or inductive method. Or if you were going to teach some similar things about AIDS to kids in high school, you might want to use a more constructivist method. So it all depends on the context that you're in and who your audience is. This is what I mean about instructional designers designing for the learner and also the context. There are strategy models and process models. Dick Carey's model is more of a process model. However, here strategy models come in handy at this part of the model. I'm going to show you a model that's commonly used in instructional design. It's called Gagne's Information Processing Model, which is an internal model of mental processes. I'm going to link it to Gagne's 9 events of instruction, which are external learning supports for the internal mental processes. Gagne's 9 events is often called a directive strategy model, but it can also be used in combination with a constructivist idea. The 9 events are gain attention, inform learners of the objectives, stimulate recall, present the stimulus, provide learning guidance, elicit performance, provide feedback, assess performance, enhance retention and transfer. Gagne's information processing model looks like this. We take in information through our eyes or any of our other sensory mechanisms, and this is called input. And that reception of patterns of neural impulses hits our sensory register. We then act upon selective perception to read what we see or hear or feel, and we only select a small part to put into our brain. This goes into our short-term memory, which is usually only 7 units long. We rehearse that information in order to keep it available to be able to put into our long-term memory. We also semantically encode it so that we can store it into that long-term memory. We work with this process of storage so that we can retrieve it later. Then when we retrieve it, it goes back into our short-term memory and then into our response generators, which again are those things like our eyes, ears, hands, feet. Next, we organize that response and it comes out on the other side in some kind of performance. One of the things that we do in instructional design is make sure that we have that feedback and reinforcement at this point to make sure that the student retains the information in their long-term memory. Now I'm going to link this to Gagne's 9 events. First of all, gaining attention. That's not just whistling or telling the students it's time to start, but it really is a way to get students involved and excited about the instruction. So showing a short YouTube video or some kind of other thing that's interesting, starting off with a fun experiment that explodes, would be one way to do this. The first part of the information processing model for gaining attention, and this is a different way to look at that information processing model, is that we have the environment here. That might be the classroom or the website or however else the information is delivered. And we see again our receptors. Those would be our eyes, ears, hands, or anything else we use to get the information in. That's where the gaining attention part of Gagne's 9 events takes place. Next is informing the learners of the objectives. We want to make sure that they know what to expect. I wonder what it takes to get an A? Is this going to be useful? I wonder what he expects of us. Students often think that. I'm so bad with computers. Expectations are not necessarily always positive. Let's look at how that plays into the information processing model. We have our expectancies up here because what we expect may often occur. If we expect bad things to happen, we may have a lot of fear about what's going to happen. But if we feel good about something, we also probably will be more successful. But making sure of informing learners of the objectives helps students know what to expect. Next is our executive control. The executive control would include things like our prior experience, our gender, our culture, anything that might impact our ability to learn. Stimulating recall is the next. What we're trying to do in this step is to make sure that people can attach what they've learned before to what's new. Stimulating recall might be telling a story, might be asking them to review what they've done last week or in their homework. So it's somehow attaching what's new to what they already know. Okay, so how does this work in the information processing model? This is where we use retrieval. You're asking people to come up with what they already know, bring it into short-term memory so they can attach the new learning to that old learning. And that way it makes it more concrete in their memory. That way, when it's stored in their long-term memory, they're more able to access that information. Next is presenting the stimulus. Here is the stimulus. What Gagne meant here is really present the lesson, but the reason he called it the stimulus is because of his behavioral background. And what this really meant is stimulus, of course, often means that we respond. So it implies that there's more activity than just standing up and providing a lecture. How do we look at that in the information processing model? Here we have that selective perception. This is where we make sure that students pay attention to what we want them to see in their sensory register. Remember, when we see something or hear something, we don't necessarily get all of it in. So we have to pay attention to certain aspects. Providing learner guidance is helping students go through step by step a problem that you're providing, so that later they can do problems on their own. Okay, now I get it. So in the information processing model, this deals with taking things from short-term memory and trying to create semantic encoding, in other words, making the things that they see and do into semantics in their brain. This way, it's encoded into long-term memory so that they can retrieve it later. Eliciting performance, often called practice, is the process where we let students solve problems on their own. Let's do another one. Now I'm getting the hang of this. The idea is that we watch their behavior and see if they're able to retrieve the information for their long-term memory to perform. So now what we're asking students to do is pull what they have in long-term memory out and organize that response. Then their response generator, which is part of their brain, will actually now send that information out. In terms of providing feedback, we have something called the feedback loop. Practice and feedback is what helps cement the learning. So it's important to give good, critical feedback, both positive and corrective, for students to be able to learn. So in the information processing model, what we're doing is seeing what they now have in long-term memory and reinforcing the correct behaviors. This also will change the executive control, because if students are successful, later they're going to remember that. They'll know what strategies they use to be successful. Assessing performance is the next step in Gagne's 9 events. This could also be evaluation or testing. A lot of times, though, students find that the assessment doesn't match the objectives that they had or the practice that they had. We always need to match the objectives, practice, and the test. Here's a little story. Once there was a science teacher who just had gotten a new piece of equipment, a nice microscope. Her objective in the class was that every student would learn to use the microscope properly, but it was a very expensive microscope. So what she did is she set up the microscope perfectly and had each student for their practice come and peer into the microscope. They weren't allowed to turn the knobs or mess with the settings. They went back to their seats and later had a test where they labeled each of the parts of the microscope. Now ask yourself, do these things match? So it's critical to match the 3 objectives, practice, and test to be successful. So if your objective is to make sure that the students can use the microscope, they're actually going to have to use it in both their practice and their test. That's better. So when we're assessing performance, we're asking students to pull it out of their storage or long-term memory, organize their response, and then use their effectors, their hands and feet, to show us what they have learned. And when they have done this, this will tell us whether they've learned the information. Next is enhancing retention and transfer. A lot of people confuse this and say, well, at the end of the process they should have done this, but this is where they actually take the information and they totally get it. It's where they start to use the information in the real world. What we're looking at here in the information processing model is seeing them use it in the environment that they're in. So for example, if they have a lesson on the right foods to eat, we might send them out to a fast food place and ask them to look at the food they're eating and decide which things are healthy and which things are unhealthy. This changes their executive control, again, because it's the idea that now it's solidified and next time they use this information, they will have control over it. Here are some more strategies that are common to instructional designers. Examples and non-examples are often used because it's found that by looking at other people's mistakes, it's easier to see your own. Here's an example of a beautiful beach and one that's been destroyed by trash. So it's a good non-example for recycling. Examples can be similar. So if we're teaching somebody the definition of a sphere, we would probably show them something like this, which is a circle. But we would also need to show other examples. You need to show multiple examples so people understand what the class looks like. In other words, they would be able to classify these later. Then the non-examples can be something that's very different, but that really isn't enough. You also need to show them things that are relatively similar, but why they aren't spheres. For example, this multi-pointed star over here is round, but it's not really a sphere. The other looks sort of round, but it's got its corners cut off. And then we have a quarter round, which is also not a sphere. So these come outside of the definition of the sphere. So if we were to classify these, they would not be in the realm of spheres. Advanced organizers are similar to examples, except they involve the use of a metaphor. We have the vehicle, which is the metaphor, and the topic. If we were a teacher talking about what it's like to raise children, we might use a flower or a plant as the vehicle. But there's certain grounds for that being the vehicle, but there are also limitations to using it. The grounds, for example, would be that similar to plants, when you have a child, you plant the child, you feed and water the child, you nurture the child, and you train the child. The limitations, on the other hand, are that humans are a lot more complex, they take a lot more time, they have a lot more value, and they live a lot longer. So if you're advising students, you might suggest they start with a plant. Let's take a look at this example and non-example. The example is a good one. It shows you exactly where your nut, your nub, your husk, and your kernel is. So that would help you learn your objective or your skill, discriminate husk. But if you look at the non-example, that's really not helpful. It's really a non-example of how to do a non-example rather than a non-example of discriminate husk. A non-example should actually help learners' ability to discriminate, and this doesn't. Think about what might learners confuse the husk with. Would it be the kernel? Would it be the nut or the nub? What would be confusing? Is it even important to have a non-example here? Often you can use other terms they are learning, or what looks similar. The non-example should be meaningful in some way. There are also feedback strategies. Most of you have heard of reinforcement. There are 3 types: positive reinforcement, negative reinforcement, and punishment. A lot of times people confuse negative reinforcement and punishment. Let me show you the difference. Here's an example. Don't eat candy before dinner is the rule. If you eat everything on your plate, you can eat some candy. That's positive reinforcement. Negative reinforcement is that the parent removes the candy. I'll spank you if you touch that candy is punishment. Can you now see the difference between punishment and negative reinforcement? With negative reinforcement, all you do is remove the stimulus that causes the bad behavior. Punishment is different. It's where you actually punish somebody for the behavior. There are certain feedback strategies that are appropriate for Gagne's learning outcomes. For example, a incorrect strategy works well for verbal information because it's either right or wrong. But correct given a correct answer could work for verbal information or intellectual skills. Information and self-correct also work for intellectual skills. Where something is faulty and you self-correct can work for intellectual skills, problem solving, and cognitive strategies. Providing consequences helps for attitudes. Sensory can help for psychomotor. That's the idea that you say, you feel that pinch right there? You're leaning over too far when you try to swing your golf club. Progress can be used in all areas. More strategies. I really like these because it fits well with instructional design. What I hear, I forget. What I see, I remember. And what I do, I understand. Most instructional designers use a lot of visuals as well as a lot of activities that help people actually do what the behavior is. Even after you've chosen a strategy, there's certain components that you should think about, such as organizational strategies, macro strategies like scope and sequence, or micro strategies, in other words, expanded instructional events, or delivery strategies, media selection, how you're going to group students, as well as management strategies, how you're going to schedule, or the acquisition of resources. So there are many things to think about with instructional design. In terms of macro organizational strategies, we can look at things being world-related, like space, time, physical attribute, or utilization-related, procedures, frequency of use, things that are inquiry-related, project-based or problem-based, learning-related, prerequisites and familiarity, or concept-related, concepts, principles, and procedures. Again, there's lots of things to think about when you design. Let's look at a prototype strategy set. This is something that you'll create to have reviewed by other designers or your content expert. First of all, you have your behavior from the hierarchy, the objective related to the behavior, and then your information presentation related to the objective and the behavior, your examples and non-examples, your pretest, embedded test or activity with feedback, as well as your post-test. Let's take a look at what this looks like. Okay, so here's your behavior. Identify qualities of harmful positions. Our objective. Given the list of position descriptions, the student will correctly select those that are harmful. And then our information that provides enough information so that your subject matter expert will be able to see what it is that you intend, but not so much that you spend all your time doing this instead of getting on to the business of creating your instruction. I like this because the designer who put this module together actually bothered to put the rule in. Here are examples and non-examples. What you want to do when creating non-examples is to use common errors or misconceptions. So for example here, a lot of times we think it might be harmful to sit in an awkward or strange position, but it actually isn't. It keeps your spine flexible. Here is our pretest, our student practice or embedded test question. The purpose of this is for your formative evaluation. I usually allow my students to only create one of these that's the same as the pretest, rather than creating 4. If you're really doing good instructional design work, you could create 4 to really make sure that your project is working. Last but not least, the post-test. All of these 3 need to be parallel. For your embedded test question, you wouldn't provide feedback, but you certainly would if it were practice. Practice and feedback, remember, is an important part of instructional design. Make sure, though, that the feedback is corrective. Helpful hint is that you can actually create non-examples from those distractors that you've developed in your evaluation items. What works and what doesn't? Make sure that your objective is clearly matched in all other parts of your strategy. Be sure to differentiate between visual knowledge and conceptual knowledge. Both are important. Examples and non-examples should be plausible and useful. Make sure to create meaningful feedback. Now I'm going to show you how I would review someone else's work. Our behavior is discriminate. The problem is our objective is identify. Already these two don't match. In my information, I'm supposed to be telling the difference between kernels. That doesn't match either my skill nor my objective. What I'm seeing is that I'm supposed to classify. That is, sort good from bad. Already our items don't match. Here are some excellent examples and non-examples, though. You can see clearly from the pictures what a viable kernel should look like and what a not viable kernel looks like. Now here's our test. Uh-oh, our test is only text. To be considered viable, and it has a list of items, but this does not match the objective. There are actually two possible in the instruction: being able to classify the pictures or being able to identify or define verbally a viable kernel. This is a good item for the second objective. Notice D is not very plausible. Remember, feedback should be corrective and answer why not. The incorrect answers, or the distractors here, don't do that. Learning management is an important part of your overall strategy. Remember that your prototype strategy is different from your actual module or lesson that you create. The prototype strategy is designed to be able to show it to other designers or content experts that you're working with before you proceed to costly development of multimedia, video, or other types of media. Make sure that you use a logical chunk size per chapter. That would be the number of objectives or practice items that you cover. You do this based on your audience. Smaller chunks of 2 to 3 objectives for younger or less experienced learners, and larger chunks 4 to 6 objectives for older or more experienced learners. When you're creating books or ebooks, make sure to create a table of contents, number the pages, provide a notes column, use symbols to enhance the location of the information, such as activities or feedback. Also, for any type of media, use pictures to enhance meaning or motivate, but make sure that they don't distract. Plan the placement of your assessment instruments and feedback carefully. Use descriptors like below or in the back of the book for feedback. Place questions and complete answers in the feedback, because it sometimes is hard to look back, especially if you're doing multimedia. Most critical is that your instructions, examples, and test items should be parallel. In other words, that they're covering the same behavior and objective. They should cover the same content, and they should be at the same level. There must be enough for students to successfully complete the evaluation. Find creative ways to motivate learners throughout the lesson. This is an excellent example of a terminal objective in the final layout of a module. If you take a close look, you can see all of the parts that you've been working with. It has good, easy to understand examples and non-examples, nicely done with arrows. There's a pleasing 2-column layout using boxes for emphasis. And notice the creative motivational concept that is used throughout. Here are your references for further study. I hope you'll join us next time.